Number 1, find the derivative if f of x equals secant x plus tan x multiplied by secant x minus tan x. So to find the derivative, we need to use the product rule because we're multiplying two functions here. And how we do that is we multiply the first function by the derivative of the second function plus the derivative, plus the second function times the derivative of the first function. And so that will look like. Let's work this out. Secant x plus secant x. Alright, so the derivative of secant of x is secant x times tangent of x. Minus tangent of x, so the derivative of tangent of x, is secant squared x plus secant of x minus tangent of x. Right, so again, the derivative of secant of x is secant x tan x plus the derivative of tangent of x is secant squared x. And that is number 1. Number 2. Find an equation tangent to the graph f of x equals 3 over 1 minus 10x at the point 1 negative 1/3. So the first thing we need to do is find the derivative of the function here, and we do so since we're dividing, we're going to use the quotient rule, which basically what we would do is take the denominator multiplied by the derivative of the numerator minus the numerator multiplied by the derivative of the denominator, all of that over the denominator squared. An informal term and an easy to remember term would be low d high minus high d low over low squared. So that would look like.
So let's plug this in.
So the derivative of 3 would be 0, the derivative of 1 would be 0, the derivative of negative 10x would be negative 10, 0 minus 10 is negative 10. Over 1 minus 10x squared. Now let's move it up here, we'll draw a little arrow so you know. So this is going to be 0, minus, this is going to be negative 30, so 0 minus, so it would be 0 plus 30, which simply equals 30 over 1 minus 10x squared. Now what we need to do at this point is plug in x. So that would look like 30 over 1 minus 10 times 1, x is 1, by the way, squared, which would look like 30 over 10 times 1 is 10, 1 minus 10 is negative 9, negative 9 squared is 81. 30 over 81 simplified would be 10 over 27. Now this here is our slope. Now, what we need to do is take the slope and put it, plug it into the point slope form. We'll just draw a box here. So, you know, and the point slope form is y minus y1 equals m being the slope over x minus x1. So let's plug this in. Y minus y1 is negative 1/3, which would be positive 1/3 over the slope, which is 10 over 27. X minus x1 is 1. So let's plug this in. The first thing we need to do is move the 1/3 over here. We do so by subtracting 1/3 from both sides. So it would look like y equals 10 over 27 times x minus 1 minus 1/3. Now what we need to do is distribute this. So this would be 10 over 27x minus 10 over 27 minus 1/3. So we combine like terms. Which would be negative 10 over 27 minus 1/3. We'll just draw another little arrow over here to the side. So we need to get the same denominator. So 10 over negative 10 over 27 minus 3 times 9 equals 27. 1 times 9 equals 9. Negative 10 over 27 minus 9 over 27 equals 19 over 27. Negative 19 over 27. And so our answer, our final answer, if we were going to take this back in here, is y equals 10 over 27x minus 19 over 27. And this is the final answer. Y equals 10 over 27x minus 19 over 27. Number 3, explain what is done if you are finding the derivative of a function that has a variable in the denominator. So what we would use is the quotient rule, and the quotient rule looks like this. Say, for example, we have 5 over 2 minus 6x. I'm trying to find the derivative of this. We use the quotient rule because there is a variable in the denominator. And so what we need to do is take the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So what that would look like would be, for example, 2 minus 6x times the derivative of 5 minus 5 times the derivative of 2 minus 6x all over 2 minus 6x squared. So let's bring this up here. So what that would look like, 2 minus 6x, the derivative of 5 is 0, minus 5 times, alright, so the derivative of 2 is 0, the derivative of negative 6 is 6, 0 minus 6 is negative 6, times negative 6 all over 2 minus 6x squared. Bring it down. 2x minus 6x times 0 is 0. Minus negative 5 times negative 6 is 30. So it'd be plus 30 over 2 minus 6x squared, which would equal 30 over 2 minus 6x squared. And this is the quotient rule. Number 4 says, explain what is done if you are finding a derivative of a radical function. So for instance, if we had find the derivative of x cubed, for instance. So the first thing we need to do is change how this looks. And how we do this is we change the radical to an exponent. So it would look like, now we use the chain rule, which looks like this. We take the exponent and bring it to the front. X, then 1 half minus 1 times the derivative of what was in the parentheses, which would be x to the third. This equals 1 half times x to the third. 1 half minus 1 is negative 1 half, and the derivative of x to the third is 3x squared, because we bring our exponent to the front, which would be 3x, and then our exponent minus 1, which would be 2. And to solve for this, we multiply this by the 1 here, so it would be 3x squared over 2 times x to the third to the negative 1 half power. And this is the answer. Okay, this is number 5. Looking at number 5, we can see that two functions are being divided by each other, so that's automatically the quotient rule. The quotient rule is better known as low d high minus high d low. All over low squared. So if we plug this into this equation, we can get negative 3x minus 2x to the 4th times the derivative of the high, which is the numerator, which is 2x plus 5, minus 2x plus 5 times the derivative of the low, which is the denominator. Okay, so now we start taking the derivatives out. The derivative of 2x is just 2. The derivative of 5, the constant, is 0. The derivative of negative 3x is negative 3. And the derivative of negative 2x to the 4th is negative 8x cubed. Right. So now we can start multiplying. So 2 times negative 3x is negative 6x. And 2 times the negative 2x to the 4th power is a negative 4x to the 4th power. And that's this side. All minus. So since everything on this side is behind the subtraction sign, the subtraction symbol, it would take the negative, it would take the place of a negative number if it was positive, and if it was positive, it would be negative. So this would be negative 3 times a negative 2x, which is positive 6x. A negative 3 times a negative 5 is a positive 15. Negative 8x cubed times negative 2x is a positive 16x to the 4th. And a negative 8x cubed times a negative 5 is a negative 40x cubed. And like I said before, since it's after the subtraction sign, everything gets the same. So this is minus 6x minus 15 minus 16x minus 40x cubed. And now we can combine like terms. So we have a negative 6x minus 6x is a negative 12x. A negative 4x to the 4th minus 16x to the 4th is a negative 20x to the 4th. We have 15, that's all I know, the negative 15, and a negative 40x cubed. All over the denominator squared, which is 3x minus 2x to the 4th squared. And that's the derivative for number 5. Number 6 is to find the derivative of this function here. And as we can see, there's more than 4 different polynomials in this equation because they're all separated by an additional subtraction sign. And we have 4. Then the first one is 2 over x to the 5th power, and we can see that would mean is being divided by, so that's the quotient rule. So we know the quotient rule, in other words, is known as the equation is low d high minus high d low all over low squared. And if we plug the first polynomial into this equation, we get x to the 5th times the derivative of 2 minus 2 times the derivative of x to the 5th over x to the fifth squared. So we know that the derivative of a constant will equal 0 because you see no x. So the derivative of 2 is 0. The derivative of x to the fifth is 5x to the fourth. And all that once again over below square, which is x to the fifth squared. Now we can go into doing our simple algebra. So x to the fifth times 0 minus 2 times 5x to the fourth all over x to the fifth squared, which will equal x to the fifth times 0 equals 0. Negative 2 times 5x to the fourth is negative 10x to the fourth. So we can't leave the denominator like this since it's not just a quotient rule. So we do our math. 5 times 2 is 10. So that's x to the 10th over 10x to the 4th. And we bring an exponent from the denominator to the numerator. So that's basically, which will then give us negative 10x to the negative 6. And that's the derivative of our first polynomial. Our second polynomial is nothing but the power rule, which will equal negative 11x to the 10th. The derivative of the second polynomial. The third polynomial is a trig function, cosecant. The cosecant of 4 will automatically be 0 because 4 is a number on the number wheel, so we can determine it. So the last one is a radical, a negative radical. And we can change that by making it into the chain rule. And we make it into the chain rule by taking whatever is under the radical, put it in parentheses, and take the exponent over the radical and make it into a fraction, which will be 1 over 4. Negative. And now we start doing the derivative for the chain rule. So we bring the 1/4 in front of x cubed, leave this in parentheses. 1/4 minus 1 is a negative 3/4 times the derivative of what's in the parentheses, which is x cubed. The derivative of x cubed is 3x squared. And now we multiply all of this together, 1/4 x cubed to the negative 3/4 times 3x squared, all gives me 3x to the negative 1/4 over 4. And this is the derivative of our last function. So the derivative for the whole problem will be our first derivative, which was negative 10 x to the 6 minus our second one, which was negative 11x to the 10th, plus our third one, which was 0, and minus our last one, which is 3x to the negative 1/4 over 4. And that's the derivative of number 6. This is number 7. It says to explain the product rule. The basic definition of the product rule is multiplying, well, having two functions, but multiplying the first function times the derivative of the second function plus the second function times the derivative of the first. Okay, so first we just find the derivative. The derivative of natural log is 1 over x. We see that. The derivative of x cubed is 3x squared. And we bring down our first and second terms. We multiply across x cubed times 1 over x is x squared plus natural log times 3x squared is 3x squared times the natural log itself. And the derivative of our original equation, x cubed times natural log of x, using the product rule, will be x squared plus 3x squared times natural log x, using the product rule.